So our notes for today are graphing tangent and learning about the equation's attributes. But first, we're going to start with the parent function. So the parent function of tangent, I'm going to sketch the graph off to the side. So I'm going to start with x and y. I'm going to start with x and y, and then I'm going to plot a couple of points and put on the asymptotes. So the tangent graph goes through 0 and it has asymptotes at negative pi over 2 and pi over 2. That one over. Tangent graphs have asymptotes. Remember that asymptotes are not actually part of the graph. They're like a guide for your graph. So the tangent graph has a center at 0. And it goes from negative pi over 2 to pi over 2. And the graph it looks a lot like the cubic, but it's not like the cubic because cubic kind of continues on forever in both directions, left and right. The tangent graph is bound by these two asymptotes, but we've got a curve that looks like that. And then, I'm going to redo that one. And a curve that looks like that. This is called a cyclical function, and that just means that it cycles. So that is the parent function right there. Sometimes if you look it up, it might show only starting at 0. So if it starts only starting at 0, then you've got just this branch right here. You'll see the asymptote, and then you'll see the start of the next cycle over here at pi. And the next branch would look like this. So again, sometimes you'll see it where it only shows these two branches, but it is a cyclical graph. So these little waves continue all over and over again forever in both directions. So while I have this graph just posted here, let's think of the period of just one cycle. If it goes from negative pi over 2 to positive pi over 2, so if you consider this one period, from intercept to intercept would also be one period. But how long is this? Well, like this distance is pi over 2. And this distance is pi over 2, or a half of pi and a half of pi. If we add those distances together, how long is that? What? You get a whole pi. If you've got a half pi and a half pi, you get a whole pi. So the period down here, we're going to say that is pi. The period for tangent is pi. Again, you could also look from intercept to intercept. So from 0 to pi, that is also pi. The domain. So this graph continues on forever left and forever right, but the graph never crosses these asymptotes. So we've got to take into account these asymptotes. And so we're going to say that x, because domain represents the x's, x is not equal to pi over 2. plus pi n. And what that means is that it says, like, if we started at 0 and you're continuing on, the graph does not equal pi over 2. And these asymptotes happen every pi. And so if it doesn't equal at pi over 2, and then you could add another 180 or another pi, it doesn't equal there. And you could add another 180 in either direction. You could add a negative. You could go the other direction too. And this happens an amount of times, an infinite amount of times. Like you could go any amount of n. So that's how you could represent the domain. The domain is not equal to wherever the graph has asymptotes. The range, how far up does this graph go and how far down does the graph go? Forever. So we could say that the range is all real numbers. The range is all real numbers. Yeah, we had a slide at the very end. It was our last day of notes where we wrote all this stuff down. We're doing it again, just more in depth. Maybe, I don't know. Or maybe you were just zoned out. The x-intercepts. So we have an x-intercept at 0, and then we have one at pi. When's the next one going to be? Pi. So you could say that the zeros are really at every pi. So you could say it's at 0 plus pi n amount of times, right? It's going to keep repeating. Or like this is the same thing as just saying that x is equal to pi an amount of times, because you could keep adding or subtracting either direction. So we will say that our x-intercepts are equal to just pi n. This is kind of how we find them. The y-intercept, what's the y-intercept? You can see it on the graph. Yep, 0. So y is equal to 0, or we could say 0, 0. That's our y-intercept. To find your vertical asymptotes, and tangent doesn't have any horizontal asymptotes. To find your vertical asymptotes, and this kind of goes with the domain. They're like the domain, x's are not equal to wherever the asymptotes are. Okay, so where are the asymptotes? Everywhere that these happen. So when we're doing our problems today, we'll ask you to find asymptotes from an equation. So what you're going to look for is the things in parentheses, the stuff in parentheses. So I'm just going to put this as like a placeholder. The stuff in parentheses is equal to wherever our asymptotes are. So again, you can start at pi over 2, and then they happen every 180 or every pi n. So pi over 2 plus pi n. So this is kind of the formula that we'll use to solve for asymptotes. We'll use this formula to solve for x-intercepts. Everybody good? These are just tangent basics. And remember that on your test or on your quiz, they're not going to have you actually graph these by hand because they can't test you like that on a computer. So they'll have you maybe do some stuff like that for like homeworks and stuff, but the way that you'll be assessed on it will be like multiple choice graphs, stuff like that, or asking attributes about the graphs. So what about transformations? So very rarely are you going to be asked to just graph a boring parent function of anything. So they're always transformed in some way, up, down, left, right, stretched, compressed, stuff like that. So some transformations. We need to know the pieces of the equation. And so I kind of wrote out the equation here. We've got the function of tangent is equal to A tangent B x minus c plus d. Each one of those things represent a piece on the graph. And so A, and this is very similar to other graphs. So if it feels tingly in your brain as we go through these, that's because they apply to other functions too. They like these types of transformations are similar when you graph a quadratic or a cubic or other things. So in front of the tangent function, this A represents our amplitude. So A is amplitude. And the amplitude is representing how far up and how far down your graph goes. It's stretching it vertically. And like I said, you've done that before when you've graphed other functions. A is the amplitude. B is what's called, and so A, B, C, and D, A just happens to be amplitude and they both start with an A. Nothing else, like these are not like acronyms. They're not like representative of the actual names. So like B doesn't stand for something with a B. Well, it kind of does, but not that's not what they are. They're just showing placeholders and order A, B, C, D, showing these places of the equation. B is called the period constant. I like to also refer to it as the speed. So the period constant can kind of like really confuse students. So the period constant is your speed, and it kind of tells you like, and it's a little harder to see on tangent. It'll be a little easier for me to illustrate for you when we start graphing tangent and cotangent. It's not what I meant to say. When we start graphing sine and cosine. But your speed tells you like how quickly you get through your cycle. So if you get through your cycle quicker, so let's say that there's a 2 there, you'll have 2 cycles where a parent function just has 1. So it's like the bigger the number is, the more cycles that you have. So it's like your speed, how quickly you're getting through your cycle. The period constant in the equation doesn't tell you anything about the period. You have to always solve for the period. So when you get a problem and it says, hey, what's the period? You have to solve for it. And so we do have a formula that helps us solve for the period. So our period here, parent function says that it is pi. And for a parent function, the number in front of the x is a 1. So that's how you get pi. It's pi divided by 1. Well, when you have something that's transformed, whatever your b value is, it's 180 or pi divided by whatever that b value is. So our formula for that is pi divided by b, or 180 divided by b. I think that the on-ramps curriculum really likes to work in radians. So this is what you see more often, but they're equivalent. Next, C. C is your, for the tangent graph, C is your center. It is also called your phase shift. Your phase shift, but for your tangent graph, it's considered your center point. And so it's what moves your graph left and right. It's your horizontal transformation. And so if you look back at the parent function, there's nothing in there with the x. So it's like plus 0. So that's why you start here, your first center point at 0. And so we're going to do a lot more exotic graphs than the parent function. And C is representing your center. And this is really important that the inside the parentheses, do you see how there is a subtraction sign? You'll see that? That means that when you pull it out of the equation, you're pulling it out in its opposite. So this equation says that it's always opposite of what you see. So if you have x minus pi, that means you move to the right because you move opposite. So I'm going to put that on here as well. I'm going to jot down opposite. And that's a big one. It's always opposite, your phase shift. Say that one more time. Yes, 100%. It is H. It represents H. And so it's always going to move in an opposite direction. And like I said, if these things feel tingly, it's because you've done these transformations before just with other functions. Like they kind of represent similar pieces as we go through. Here, D. D represents this part. Does anybody remember, like on a quadratic, what the plus K does at the end? Yeah, it's your vertical shift. It moves you up and down. Yeah, same thing with a tangent graph. Same thing. So it's your vertical shift. And it moves you up and down. And in the equation, it's a plus. So it moves the way you think it's going to move. The only one that's strange is C. C's opposite. We good so far? Let's use it. So we've got we've preloaded our brains with all of the pieces from the equation. Now we're going to go through and do some examples. The first example says find the period, and this kind of corresponds with the way that your homeworks are. The very first section says find the period of the function. And so this equation, find the period, and if you look a little bit higher up where we wrote down the period, right here, to find the period, it's always going to be pi divided by b, or if the problem is given to you in degrees, it would be 180 divided by b. So I'm going to jot that down, what our formula is. Both of these are, they can be in terms of pi or in terms of radians, it doesn't matter. But that equation, or the way that we're going to find it, is going to be pi divided by b. So first, you've got to be able to identify b. B is whatever is in front of the x. B is what's in front of the x. So for this problem, we've got b is equal to 1/4. And then for our next problem, we've got b is equal to 6 pi. So whatever it is, we're going to write it down. So for problem number 1, we've got pi divided by 1/4. Even in an advanced class, we still sometimes struggle with dividing by fractions, but we need to remember keep, change, flip. We're going to keep the top fraction the same. We're going to change the operation to multiply, and then we're going to flip the bottom fraction or multiply by the reciprocal. So we're going to multiply by 4/1. What does that equal? 4 pi, yeah, wasn't a trick question. So we end up with 4 pi. Typically, we write the number in front of a pi, but pi times 4, it's the same thing. But we will write it as 4 pi. Don't overthink it. Y'all are smart. You can do this.
It would always be like, we write it like that, or we ever like, this is pi. It's just like so.
The next problem, what am I going to write down? Pi over 6 pi. What happens? The pi's will cancel, so I'm left with what? What? 1/6. So to find the period, you look at the equation. All the other pieces don't really matter. All you need is b. And pi divided by whatever your b value is, that will give you your answer. We good? The next two problems say that we want to determine the vertical asymptotes. So we have an equation that we jotted down over here. And I said that we'll use this in a minute. So to find vertical asymptotes, we're going to take the stuff in parentheses, set it equal to pi divided by 2 plus pi n. So that's the formula that we're going to use. We're going to set the stuff in parentheses equal to pi over 2 plus pi n, and then we're going to solve for x because the vertical asymptotes are always going to be x equals equations. So let's do it. So I'm going to jot down how we're going to find it. Like I said, we're going to do the stuff in parentheses, and we're going to set it equal to pi over 2 plus pi n amount of times. So we need to know where's the stuff in parentheses. So that is the stuff in parentheses. This is the stuff in parentheses. Do y'all see any other parentheses there? No. So when I'm talking about the stuff in parentheses, that there's only one thing I'm talking about. I do want us to change something first because I know that some of you little smarty pants are going to get ahead of me. I want to look at question number 2. It's given as a decimal. I can almost guarantee that you'll have a problem like this on a quiz or on a test, and they will expect you to do that without a calculator. Y'all aren't going to do very well unless y'all remember something. So does anybody know what this number is? 6/10. It's 6 and it's in the 10th spot. So guess what? We can rewrite that as a fraction. So that is the same thing as 6/10. And trust me when I say this, it'll be easier to solve. And you won't have a calculator, so you're going to have to know how to change this in your head. So remember that any number that's there, if it was 0.4, that's 4/10. So we've got to remember to change this to a fraction because, again, I am betting that you're going to see this on a test because this is easy for them to test you on without a calculator. So what we would have to do, does this fraction reduce? Yeah, let's reduce it because it'll make it easier for us. It reduces to what? 3/5. Okay, so now when some of you start getting ahead of me, you'll know what to use. Back to question number 1 for this section. I'm going to set this stuff in the parentheses. So I have pi over 4x is equal to pi over 2 plus pi n. Asymptotes are x equals equations. So I just need to solve for x. Over here, that's where the x is. How do I solve for x? How do I get rid of multiply by pi over 4? Divide by pi over 4. And we have to remember that when you divide by a fraction, you're going to multiply by the reciprocal. So I'm going to bring over the pi over 4, and I'm going to flip it. So I'm going to multiply by 4 over pi and multiply by 4 over pi. Any questions on what I did there? I'm just isolating the x. From here, when I take a look at my fractions, it looks like some stuff will reduce. So over here, it looks like my pi's are going to reduce or cancel. What about 4/2? Yeah, well, no. Yeah, so 4 divided by 2 will just become 2. Over here, we've got pi divided by pi. And you could also take a look at this as something over 1 so that they're both fractions. So these pi's will also cancel. So when we rewrite it and clean it all up, we've got x is equal to 2 plus 4 pi. Do what? N. My pi's canceled. Thank you. I wasn't tricking y'all. My brain is still just waking up. Do y'all agree? Good. So when we are searching for or solving for the vertical asymptotes, we set the stuff in parentheses equal to pi over 2 plus pi n, and then we solve for x. And it's usually just one step. It's dividing by whatever is with the x part. The next problem, let's do the same thing. So we're going to change it to 3 over 5x, trust me, is equal to pi over 2 plus pi n. And again, we want to do the same step. We want to isolate the x, and to isolate the x, what do I do with this fraction? Yeah, I'll multiply by the reciprocal. So I'm going to bring that over and I'm going to simplify it on my paper. I want you to do it on yours, and let's make sure that we can't come up with the same thing. Did y'all get the same thing? For this problem, nothing reduces, and that's okay. Really, all that you have to do is multiply down here. 2 times 3 is 6. So sometimes a lot of stuff reduces and sometimes it doesn't, and that's okay. And again, I highly recommend that you change this fraction or this to a fraction, because I'm pretty sure that your answers tend to look like this. Then the last piece that we're going to talk about is finding the zeros or the x-intercepts. The zeros or the x-intercepts. So to find the zeros or the x-intercepts, we're going to be using this formula. So our x-intercepts are equal to pi n amount of times over b. So we have to know what our b is. So I have that's my b. That's my b. The b is always what's in front of the parentheses. So the B helps you find a lot of things. It helps you find the period. It helps you find the vertical asymptotes. It helps you find the zeros. It's a lot of useful information for your graph. So to find my x-intercepts or my zeros, and I think the homework has you find zeros, but the quiz has you find x-intercepts. So you need to know that those words are interchangeable, x-intercepts or zeros. So we're going to set x equal to pi n divided by b. Again, we're dividing by a fraction, but we can do this. Pi divided by 4. When we divide by a fraction, we've got to change flip. So this is going to turn into pi n times 4 divided by pi. We'll keep the first or the numerator the same. We're going to change the operation to multiply, and we're going to multiply. We're going to flip the second fraction or multiply by the reciprocal. Does anything reduce? Yep. And then, so I am just left with 4n. And the last question on our supplemental notes, I'm going to say that x is equal to pi n divided by b. B is 2, so I divide by 2. Can I do anything with this? No. So I box it and I'm good. How do y'all feel about the problems that we've done on our supplemental notes? Good. Okay. The next thing that I'm going to do is go through and we're going to get started on some of the questions from the exploration and from the homework. So it kind of tells you at the bottom what we're going to do. We're going to go to exploration 433 and we're going to answer questions 1 through 4.